Have you ever wondered how to graph an inequality, algebraically solve a system of equations with three different methods? There's substitution, elimination, and distribution. We get to tell you how to figure out whether an equation is a dashed versus solid line, and where you shade a graph, and also about absolute value. Have you ever looked at any of these equations and just thought, I have no idea how to do this?
All the time.
Like you're not alone.
Cool.
One of the things is whether it's a dashed or solid line. If you don't know how to do it, it's pretty easy.
Woo!
If there's this solid line, then that means it's a solid line on the graph. If
Nifty.
there's no solid line, that means it's a dashed line because there's no solid line to prove it.
How do we know which side of the line to shade? You want to use the plug-in method. So you'll want to plug in a simple number like 0, 0 to your equation. For an example, we're going to plug it in to x plus 1 is greater or equal to y. 0 plus 1 is greater or equal to 0. 1 is greater than 0. So it is 0, so you will shade it 0, 0.
Now that we have figured out which line to put and where to shade, we're going to try some practice problems. This we're going to do y is less or equal to x plus 5 all over 2. Since we already know how to graph a simple equation like this, I already graphed it. What we have to know is whether to make it a solid or a dashed line. Since there's a line under the symbol, it'll be a solid line. So I'm going to draw that in. Now we need to know what part to shade in. So we're going to plug in 0, 0. 0 is less than or equal to 0 plus 5 over 2. That equals 0 is less than or equal to 2.5, which is true. So we're going to shade in the side that's on 0, 0. So, shading that in. Now we're going to do a second example problem. This time we're going to do y is lesser than or equal to x squared minus 2x plus 1 all over 2. And since we already know how to graph a parabola, I already did it. We just have to draw in a solid line because there is a solid line under the symbol. So, drawing it in. Now we need to know where to shade. So I stuck in 0, 0 to the equation. 0 is less than or equal to 0 squared minus 2 times 0 plus 1 all over 2. 0 is less than or equal to negative 0.5. And that is false, which is not true. It is false. So we do not shade in the part with 0, 0. So we're going to shade in this part. We are going to do one final graphing inequalities practice, which is y is greater than the square root of x plus 2 plus 4. And it is not a solid line, and so this line becomes a dashed line. I already graphed it since we all should know how to graph square roots. So to know which side of the graph we plug in now, or we shade in, you plug in 0, 0. 0 is greater than square root of 0 plus 2 plus 4, which equals 0, is greater than 5.41, which is not true, and so we do not shade in the part with 0, 0. So we shade up here. Now we're going to do solving systems of equations. There are three types of solving systems of equations: elimination, substitution, and graphing. Go. We're going to start off with elimination method. Elimination method is when you get rid of a variable. So we're starting off with a simple equation like y plus x equals 3 and y minus x equals 7. One variable has to be the same as the other equation so you can eliminate it, and both x's are the same. So we're going to add going down to get rid of the x's. Y plus y equals 2y. X plus a negative x is no x. 3 plus 7 is 10. To isolate y by itself, you have to divide by 2. So that equals y equals 5. But then you have to plug that back into the original equations to get x. So 5 minus x equals 7. You subtract 5 from both sides to get negative x equals 2. You want to distribute that negative so x is isolated once again, and so x equals negative 2 and y equals 5. That's how you do the elimination method.
Go.
Substitution method is when you substitute. So we're going to start off with an equation. Y equals 5 plus x and 2x plus 2y equals 30. So you can substitute that y in this equation because you know what y equals. And so we're going to put 2x plus 2, 5 plus x equals 30. And now it's just a simple equation. So you distribute these, which equals 2x plus 2x plus 10 equals 30. These can add together to 4x plus 10 equals 30. Then you subtract 10. 4x equals 30, equals 20, just subtracting 10. Divide that by 4, and you get 5. But then again, you have to put that back in the equation. So 5, this equals 5, plus 5 equals 10. So y equals 10. And you can always check that with your next equation. Our last method is graphing it. We're going to start off with two simple equations like y equals x and y equals 2x plus 1. You graph both of those, and since we already know how to graph simple equations like these, I already graphed them for you. But then you come down and you're going to see where the two intersect. They can intersect at several points, or they can just intersect at one, like this graph. And it intersects at -1, -1. And this ends up being your x, and this is your y. So x equals -1, and y equals -1. We're going to do a practice problem for elimination method. We're going to do 7y plus 2x is greater than or equal to 5, and 3y minus 4x is greater or equal to 20. These are the two equations, and we're going to do the elimination method on them, but we don't have any variables that are similar. So what we need to do is make two variables that are similar. We can make x similar because we can multiply this by 2. And so that becomes 14y plus 4x greater than or equal to 10. So now we can add going down because these are the same. So 3y plus 14y equals 17y. And negative 4x plus 4x is no x. And 20 plus 10 equals 30. Now you're going to divide this by 17 to get y is greater than or equal to 1.76. Now you have to plug it in to the rest of your equation. So 14, pause it. Now you're going to divide that by 17 to get y equals or is greater than 1.76. Now you're going to plug that in to your original equation. So 1.76 times 7 equals 12.35 plus 2x is greater or equal to 5. So you want to subtract this from both sides. To get 2x is greater or equal than 7.35. Negative 7.35. Then you divide that by 2 to get your x, which is x equals negative 3.68. So y equals or is greater than 1.76 and x is greater than or equal to negative 3.68. Now we're going to do an example of a graphing method. Y is greater than or equal to the absolute value of 3x minus 8 all over 2. And y is less than or equal to negative 4x plus 13 all over 2. I did it alright down here. I did a table so you can see all of the numbers once it focuses. And so, since we already know how to graph simple equations like these, once it focuses, maybe, like these, now that it's focused, I already graphed them. And they are solid lines because there is a line under each of these symbols. So, up here, I will draw them in. Each of the equations are drawn right here. But we need to know which side to shade, because if you shade one side, it also, when you graph two inequalities to figure out what they're equal to, it's where both are shaded. And so you're going to shade in both and then figure out where they cross. And so we're going to do the first one. So I plugged in 0, 0, and then it turned into negative 8 divided by 2. And so 0 is greater than negative 4, and that is actually true. So you're going to shade in the side with 0, 0. So you're going to shade down here for this equation. And on this one, it turns into 13 divided by 2. And 0 is smaller than 6.5. And so you shade in this part with 0, 0. So shade in this, and wherever they match. So from here over is where they overlapped. And so that is the answer to your equation.